At the heart of some of the largest factories ever built are machines so massive they don't even resemble machines. They resemble structures. Towering frameworks of steel and concrete, rising multiple stories high, anchored deep into the ground as if they were part of the earth itself. These are hydraulic forging presses, industrial systems capable of exerting thousands of tons of force in a single, controlled motion. Unlike traditional machines that rely on impact, these presses don't strike, they don't hammer, they apply pressure, steady, deliberate, and precise. And with that pressure, they reshape solid steel, not just on the surface, but deep within its internal structure. It's a level of control that older methods could never achieve. But what makes these machines truly remarkable isn't just their size or their power, it's how quietly they operate. Step onto a forge floor, and the first thing you notice isn't noise, it's atmosphere. The air feels heavier. Heat radiates outward from freshly heated metal, wrapping around you in waves. Every surface seems to carry warmth. Even the ground beneath your feet feels alive, humming with a low, constant vibration. Above you, the press stands still. Massive columns stretch upward into shadow, supporting a structure that feels less like a machine and more like a building designed for a single purpose. And yet, at a glance, nothing about it feels immediately dangerous. There are no flashing warning lights, no violent movements, no sudden bursts of energy. Just a machine, standing still. And that's exactly what makes it deceptive. Because danger here doesn't announce itself. It waits. Unlike heavy machinery, there's no sudden impact to warn you when a hydraulic press is in motion. No explosive force, no dramatic acceleration. Everything about it is controlled, predictable, measured, until it begins to move. When the press activates, the upper die starts to descend, slowly, smoothly. There's no slam, no rush, just a steady closing of distance. And at this scale, speed becomes irrelevant, because when thousands of tons of force are involved, even slow movement becomes unstoppable. By the time you recognize what's happening, the outcome is already determined. But this design wasn't created by accident. It was the result of a problem that early industry couldn't solve. Before hydraulic presses, forging relied heavily on steam hammers, massive machines that shaped metal through repeated, high-impact blows. They were loud, violent, visually powerful. And for a time, they worked. But beneath the surface, something was going wrong. Each strike introduced stress into the material. Tiny fractures formed deep inside the metal, too small to see, but significant enough to weaken the final product. Components that looked solid would fail later under pressure, not because of what engineers could see, but because of what they couldn't. Hydraulic presses changed that. Instead of striking metal repeatedly, they applied continuous pressure. This allowed the internal structure of the metal to shift, compress, and realign. Weak points were reduced. Density increased. Strength improved. It was a breakthrough in manufacturing. But it came with a trade-off. Because the force didn't disappear, it became contained. Inside the system, immense pressure builds within sealed cylinders, thousands of pounds per square inch, held in place by valves, seals, and structural integrity. And when that pressure is released, it doesn't scatter. It follows a single path. Direct, controlled, uninterrupted. There's no hesitation, no adjustment, only motion. And once that motion begins, it cannot be negotiated with. As hydraulic presses evolved, they didn't just become more powerful, they became larger, much larger. At a certain point, Installing one of these machines wasn't just about placing it inside a factory. The factory had to be built around it. Foundations were dug deep into the ground, sometimes extending dozens of feet down, anchored into bedrock to stabilize the immense forces involved. Because at this scale, even the ground itself becomes part of the system. Every component had to be engineered to handle extreme loads. Columns thicker than tree trunks, structural beams longer than entire buildings. Everything designed with one goal: to channel force in a single direction without failure. By the mid-20th century, these machines had become essential to industries where strength and reliability were critical: aerospace, infrastructure, heavy manufacturing. Components that once required multiple parts could now be forged as a single piece, eliminating weak points and increasing durability. But this also created dependence, because once a system is designed around a single massive forging, only a machine of this scale can produce it. Despite all this complexity, operating the press often came down to something surprisingly simple: a control input, sometimes no more than a small lever or button. And that simplicity created a disconnect, because while the action felt small, the consequences were nothing but. On the forge floor, workers operated within precise routines: heat the metal, move it into position, step clear, activate the press, repeat. The process was structured, efficient, predictable, but it left no room for error. Because the machine didn't adapt, it didn't react to hesitation, it didn't compensate for mistakes, it simply completed its motion. And most of the time, incidents didn't happen because of catastrophic failures. They happened during ordinary moments: a slight delay, a miscommunication, a task that took just a few seconds longer than expected, residual pressure still present in the system, a routine action performed out of sequence, small deviations with irreversible outcomes. Because once the press begins to move, there is no stopping it in time, only the realization that it's already happening. Over time, industries recognized the risks. Safety systems improved, protective barriers were installed, lockout procedures were introduced to control stored energy during maintenance. Operational protocols became stricter, more disciplined. These changes made a difference, but they didn't eliminate the danger. Because at this scale, force isn't something you can remove, it's something you manage, something you respect. Today, hydraulic forging presses remain essential to modern industry. They shape components used in environments where failure is not an option: aircraft structures, heavy transport systems, critical infrastructure. Their role is quiet but foundational. And despite decades of technological advancement, their core nature hasn't changed. They are still massive, still silent, still controlled, and still capable of delivering immense force with a single movement. Not through speed, not through violence, but through precision. That's what makes them different, and that's what makes them dangerous. Because the most powerful machines aren't always the loudest. They're not the ones that draw attention or create spectacle. They're the ones that operate quietly, consistently, and without hesitation. Machines that don't need to appear dangerous, because they already are.